Am I live? I think I'm live. Also, it's grabbing me as I need to go get my glasses too. All right. Where are they? Today I am a lot less organized, but I think that's mostly because I'm even more tired than normal because I didn't get to sleep until after midnight. Which is a silly thing to do when I also know that I want to wake up at 6 a.m. in order to, do this stream. All right, so today is probably going to be a little bit more interesting for that, but I also want to show off what messages we got yesterday because we got a few more interesting things. Also, my YouTube is auto-tweeting for me whenever I go live, and I'm not sure I like that. Because I've been tweeting myself manually. Or maybe I'll just let it do its thing. I don't know. I'll figure that thing out in a bit. So, also it shows 2 people watching. I haven't even set up my iPad yet to get chat. So, hello anybody who's here and watching. Good morning. This is our standard Rust learning stream. And where is my channel? Here it is. And remove the audio. All right, everything should be looking good. All right. And open up chat. Okay, so yesterday, let me see if I can find this. Got a few more sort of issues added to the learning Rust. I bring this out here. Yeah. So one of the things is string, string, and string. Now, Danny Fritz sent this and basically said, "Hey, it's a there's this I think I may have mentioned this on the stream. No, it's only 21 hours ago, which is it should have been 24 hours ago if it was this. Yes, I can do time math in my mind. All right, so basically, I had been running into the problem where I was trying to sort of use strings, and then the compiler from Rust was telling me, oh, you can't do that because you have a string, or you need to borrow this string or set the lifetime of this string to be static. And it was feeling very confusing, and it was feeling like one of those things where the compiler is sort of, going like, why won't you understand me? I'm speaking this language. Please speak my language so I can tell you what's really going on so you can fix it. So that's what this is for here. And the big thing is that there are, and it's not really that there are 3 different string types, but to begin with, I guess it might be helpful to begin that way and then sort of understand how they all interact with each other. So Danny has this great message here. He also links to a blog post from somebody else when they were going through the Rust book and they ran into this issue and they wrote an article about it. The basics that Danny talks about is that the reference string, because of the reference character, is basically just pointing to the area in memory. And then you can use the static method string from to convert into string. And then string itself, just like plain string, is just like what we think about in Java. It's that sort of like, okay, that's a string, but it gets a little bit more complicated. Fshoot, who I now know is Felix. So thank you, Felix, for another great article here. I really love the fact that we're putting these in issues because they're just going to stay here, available to anybody else who stumbles across this and wants to read about like what's really going on. Okay, so Felix talks about what really is going on behind the scene in the difference between string, string, and string. So the first thing is, let's just talk about string capital S. And the reason I want to start there is because that's kind of where it feels like what other languages are using. But there are some like really big concerns with using it, and I can totally understand why some people might not want to use them in Rust. Specifically, string doesn't have a length. Like you can't just say, oh, here's the string and it's going to be X characters long. So I learned C way back in 2006 or so. And while it's true that I haven't really like specifically used C very much, like especially in the wild since then, but the big thing is that strings in C require you to put in how many characters, essentially, how much space in memory that's going to take up. So a capital string here is not equatable to strings in JavaScript. But then again, there are no strings in C. Sorry, did I say JavaScript? That's the early morning for me. Because in C, you would really just have characters in an array linked together. And that's how we would get strings. But strings here might remind us of strings in Java or other languages, potentially JavaScript, where we're allowed to grow or shrink the string and it's just fine. Well, the reason why it would allow us to do that is because it's using the heap as a place to store in memory. Now, something else that I just thought about maybe potentially mentioning here is, if you stumble across this video and you think that this is the video series to watch to learn Rust, like I am going to teach Rust through these videos, that assumption is incorrect. And for those of you who are watching through this, you know exactly the reason why. It's because I am learning this through this. And so I want to sort of treat these videos as a let's learn together. I'm learning this. I'm going to make explanations as I understand them at this time. They might be horrifically wrong, and in future videos we'll find that out. So please don't take my explanations of strings as sort of like the sacred, this is how they're working, this is how Rust is doing it, but more of I'm going to continue doing sort of these explanations as more of me settling my like, okay, I want to settle this in my brain as how I understand it right now. Then I'm going to try to use it. And if I'm wrong, that's fine. The growth mindset part is going to be, okay, now I can sort of like change the mental model about how it's working in my mind and go on with it. And I'm not going to be upset at all about the fact that I may have learned something wrong, because that is part of the learning process. Okay, so off of the rant tangent, strings, capital S, are using the heap for like where to store their place in memory. And I forget like the very details, like where in like the physical part of the computer the heap is stored. But one of the, and I wish I could plug my Wacom tablet in for this, but all of my USB ports are being taken up right now, and that means I can't draw anything. But the general idea is we can think of like the heap as this pile of stuff, and we just toss something in there. And that will be our string location. And because we just toss it in there, we don't say, oh, I need X amount of space. We can now grow and shrink it as well, as long as we don't run out of memory in the heap. Now, something that looks like this is different. This is where we're talking about And this is where like the memory locations themselves, and you like if we see these like U0X, those are the registers. That's what like the language itself is taking care of where these are. And so whenever you hear me talk about references, it's pointing towards this specific location in memory. So a string is really just like that position in heap. A str, which thank you, Felix, for pointing out that I should just say str not as string but str, just to make sure that we all know what I'm talking about. An str is not in heap, but actually the memory itself, which does need to have a beginning and an end and is immutable. And immutable meaning that I cannot change how many spots in memory it's taking up. And that's because if I did, I might access the wrong things in memory. And that's something that is run into in C, C++ a lot, because you can accidentally call for some, like if you have a string, you can say like, oh, I want position 10 of the string, but the string is only length 9. Well, the language kind of will just give that point to you. And if there's a function that actually does that, there's a chance that they'll return that or dump it out to a log or something, and there could be part of a password in there. There could be part of a username. It could be part of a SSL certificate. It could get really bad. So Rust won't allow you to do that by just creating all these different types. So STRs are just like, okay, we're going to be in here. It's going to be exactly this length, and you're not going to change it no matter what. We'll just sort of destroy the entire thing. Now the heap stuff, because it's in a different area of memory, and Felix does mention this, is that if you forget to deallocate that space in the heap, it could potentially accidentally be accessed again. Except in Rust, when the function ends, it'll deallocate it for me. It'll destroy it, which is a very nice feature of Rust to have. But something that like, and this is where I'm not completely sure, but if I are finished with that in the same function, it hasn't been destroyed yet, I'm not sure that can actually end up being a problem for me. Hopefully not. Okay, so then we have the references. So reference str is really just pointing towards the beginning of the str in memory. Now, it was like the book was like, I just realized that in the book, and let's go over there. In the Rust book here, the very next chapter, I'm kind of getting way ahead of myself by trying to learn these things. But I also personally, I find it helpful for myself to sort of go ahead, struggle with these, and then go through the book and do it appropriately. It gives me a little bit of context. So we're references and borrowing is actually in the next chapter. So I'm getting a little bit ahead of myself in the book because it's not, I mean, I get the idea that for the challenges that I'm working on from the book, I'm supposed to be just doing those probably all in the main function and not really creating these functions and passing data back and forth, except in very simple ways. I am sort of not doing that exactly, but I think that's fine. It may slow me down, but in the end, I think it will speed me up. So we've seen the compiler tell me, hey, you are borrowing this thing, and you like, but because it's borrowed, you can't do this, or you need to borrow that that str, or you need to borrow the string. And what that means is, go back here. That means is using the reference to the str is sort of borrowing it. But the reference is a read-only memory slot. It's not like a traditional C reference point where it just points to the specific spot in memory, and now I can update it, or because I thought that's what I was doing, was if I passed a reference to it, that function can now update it directly in memory. That's not exactly true. It's more of, oh, here's a read-only spot. You can't do anything with it, but you can read it and use it to create a new thing that then you return out. I thought like that sort of is helping build the mental model for what's really going on and why I'm getting errors when I try to actually do anything with the string besides using it as a read capacity to create another str or a string. And what I'm getting with that is really just a reference to the first position in memory of where it is, along with a length, which, by the way, I was trying to use length several streams ago when I was trying to get like how long this string was, and it was len, L-E-N instead. So that would have worked, but I didn't actually try the right thing. But yeah, it will say like, oh, it's here's where it begins, and here's how long it is. Compiler takes over from there. So anyways, this has just been a long, I don't know, soliloquy. Is that the right word for it? Rant. I don't think rant is the right word for it. Basically me talking about what I'm understanding things to be in right now. So thank you, Felix, for sending these. Also, Felix and Danny have sent this. I have labeled these as information, so please go check them out. I have a link to the Learning Rust in the description. But also, Avery's. I hope I pronounced your username correctly there. Please correct me if I'm incorrect in this. Sent me a description of what's going on for the destructuring inside of the function signature. So the reason why I had tried to do that was because I really like the idea of being able to destructure in the function signature and not doing it in the next line. I think it makes it a little bit cleaner, a little bit easier to read, and also allows me to pass in tuples instead of just like a bunch of different arguments. But no, okay. I did close the door, so that was good. Okay, so what it looks like I missed, and I think I missed it because I attempted to do this before I really understood functions and that I needed a return type for the function, which is that right here. I'm going to make this a little bit bigger because I notice in my preview it's looking pretty small. Right here, we need to put the type in. And what's really interesting is that this is saying, okay, the type is going to be like the name of the, so chords is like this structure that we're creating. And I don't remember if I've done structure at all in the book. I don't think I have. But this looks like a dictionary. And I had been wondering if we were going to be able to do dictionary type things. And I don't think that this was mentioned in the variable type. So this is probably going to be further into like a different section of the book. But this apparently is going to be a type essentially. Where I'm, okay, I want to describe what types are going to be in this structure. I am going to create a variable for that and pass that specifically in. And now I can destructure this directly out of here as long as it knows that it's using this specific structure, which has described the specific types in there. And then I can use them. the way I want to. So that'll be sort of interesting when I get further into it, and I'm going to come back and reference this again when I'm doing this. And one last thing before we sort of continue on, if you're watching this and you're also trying, learning Rust alongside me, that's great. I really love to have this like out there so people can on their own learn at the same time. If you have any questions, comments, thoughts, suggestions, please put it into the comments for the video. You can also create issues if there's problems. Also, feel free to pull out, fork the examples that I'm doing. You could do pull requests. I don't know if I'm going to accept those in because I'm sort of using them as my own right now, but they can be a sort of repository of your attempts for this. Also, I want this to be sort of a nice, safe space to learn and ask questions that may feel like they're not smart questions, if that makes sense. It's like, oh, how does strings work? Perfect place to answer them, ask them, because we're all learning this together. All right. So that was like half an hour of introduction to this stream this morning. All right, so with that, let's sort of get back and figure out what I was actually trying to do. In my learning Rust, right, I think the next one was generate the nth Fibonacci number. And oh yeah, you know what? I had done something. So last night, the reason I was up so late, and I think I mentioned, was I was reading these articles and they were super good, and then I just forgot to go to bed. So I actually attempted to, I haven't pushed these changes up, but I attempted to use these, use some of those principles, and I got really far. And then my power to my notebook ran out, and so therefore I didn't get it all completed. So what the big thing is that I changed these from an if to an actual match. So I was able to do this because I went through the functions and changed what they were doing. So maybe for this stream, instead of like actually writing new code, I'm just going to talk about what I've done here and what's really going on. I'm going to make this a little bit bigger. Let's move this here. We're all in the same file anyways. All right, so what is going on? Let's just walk through this this sort of application here. So we're creating a mutable variable named input temperature, and also I got the Rust stuff to work in code. Apparently, all I had to do was start opening the project in the directory the project really was, and not its parent directory, and then Rust was able to actually find Rust. So interesting. So this says that it knows that it's an F32, but how does it know that? Well, right now we can sort of, if we're the compiler, we don't know it. We're just going to put that aside and say, okay, we need to create this, but we need to figure out what it is. Same thing for input symbol. We're going to print the line temperature converter. Now, something that I've learned is that when we just have a string literal like this, this isn't string with a capital S. This is really str. So, and unfortunately, it doesn't do that because it is just a str literal. I think it's a reference str. So we create this, but it's really going to act like a reference to a place in memory where the T begins and then the length of the rest of the str. Sort of interesting things that I'm learning and trying to keep these mental models going for. All right, so then we're going to use input temperature and we're going to assign it to the result of get temperature. And because we know that the functions have to tell us what types they're going to return, now we know, like now we can go and look at get temperature and see, well, it's going to return a 32-bit float. So therefore, input temperature must be a 32-bit float. Well, okay, so we look at get temperature. And we're going to create a message, not mutable. And this is going to be the reference str to the message we're going to say. And then we're going to get the temperature and call get user input and pass it that message. So let's go get user input. Get user input is going to return a reference str. And it's going to take a reference str in, which is what that just str literal, the string literal that we created. All right, so here we're going to use the same pattern that we learned earlier on in the book, which is we're going to grab user input from the command line and we're going to stuff it in here. Now here's where I'm, the one part where I still have a problem, and it's a super interesting one, and it's sort of like I ran out of time before I can, like my computer shut off before I could really seriously work on it, which is, this is telling me that the borrowed value, so borrowed value is telling me that it's a reference str, is not living long enough before everything dies. And so if I run this code, I get a little bit more information. Okay, well, I'm not going to worry about that right now. I could change that. But, okay, user input does not live long enough. So what this is telling me is, okay, borrowed values, that's reference str, does not live long enough here because trim is sort of taking it, creating a new thing, and then returning that. And trim, according to its documentation, returns a borrowed str or reference str. So what's happening is the function is running, but it's reaching the end of the function or the end of the scope for this user input. And before trim could access the memory contents here, it's being destroyed. So therefore, it's invalid memory when trim wants it. So therefore, I'm getting this message. And that's what it's trying to tell me is, hey, you can't do that. Felix, welcome to the stream. Oh, right, yeah, I cannot return a borrowed str. Yes, I know you told me that. I was sort of experimenting around with it and said like, hey, there's no error here. But yeah, like I can do a string like this and return the heap part. And then, but because this returns a borrowed string, I could then do string, I think, was it from, to get this. And that will, I think, make this function not error out anymore. But thank you, Felix, for stopping by and helping out with us. Of course, if I do that, I think, yes, then I need to sort of like change some other things around elsewhere. But sort of what I want, I was sort of experimenting with that because I also like to see the error messages, and like I want to force the compiler to tell me that I can't do it also. And I was getting some weird, I think it was weird stuff. Like if I just return, let me just return like 4 with $str. Oh, it might not. Oh yeah, so the error goes away. The compiler isn't telling me actively that I can't do this. And I don't think there's any other problems referenced here, which I thought was really, really kind of interesting. And so, if I run this again, Avarice, welcome to the stream. Thank you for stopping by. Well, you can if it's part of the function's inputs. So yeah, it like seems to be trying to work here. And it's able to compile. So now, Avarice, what you're saying is because I'm saying I'm taking in a reference to an str, that I can then, that's the reason why I can return an str. But I'm not returning the same str, it's a different reference. So I'm not really I don't understand why that would allow me to do that if I'm not supposed, like, that's one of those things where, like, if I'm not supposed to do this, don't let me do it. Because I can abuse this. But I'm thinking that what I could do is, and I was trying to get it so that I didn't have to convert things, even though I know I can. But I could return just a plain string. And then take what I had here, which is this user input. And user input, we want to trim it. But trim's documentation says that it'll always return a reference str, which means now I need to convert it. And there's apparently several different functions for converting. And also I read another blog post last night that was talking about, I think, Felix, what you were saying, which is that toString was extremely expensive, where it has to copy the entire values into heap memory in order to, well, now that I have it as a string, as opposed to an str. But apparently, according to some blog posts, haven't verified this, that has been, the expense of it has been reduced to about the same as some of these other methods of converting. Okay, so if I do something like this, now I'm returning a string. And so this is the fun part about refactoring in a strongly typed language, is because now these other things break. But they break because there's assumptions being made about the types. And toString is the same as string from, just a different API. Oh, so it's running the exact same thing behind the scenes? Oh, that's interesting. Okay, and then, okay, so it's just doing the exact same thing. It just is, it's in front, and maybe it makes a little bit more sense than a .toString, which might be missed at the very end of the statement. So if I return converting it into a string, capital S, then this comes back to, where did we go? Get temperature, where we now put this into here. We parse it. We use the turbofish syntax, which Felix sort of told us about, in order to tell parse which version of parse we want to use to get the appropriate type of number into temperature, and then we return that. And I kind of wonder, since I'm doing this, can I just remove this line, have that there like that, and no semicolon? Oh yeah, I can totally do that. I had an extra line there. Okay, so so here we just like, okay, we're going to parse out, get the temperature, and then as soon as we have it in the appropriate, like whatever we want to return it as, we return it. So this comes back up to main, and now we have the input temperature officially inside of here. And then we do the same thing with input symbol, but here's where it gets interesting. Whereas input temperature is converting from a string to a number, and parse works like that, that makes it really easy. String string to string or string to str is a little bit different. Now I realize that what I really like, since input symbol is really just going to be a C or an F, character would actually be better. So I decided, okay, I'm going to, when I get temperature symbol, so get temperature symbol here, I might as well just return a single character, just one place in memory, because I don't need to worry about a full, like, you know, multiple sized strings or STRs or anything else. So same thing with message. We get a borrowed str. We then call get user input. We pass it our message, and we get our temperature symbol back. Okay, perfect. And this is a string that we have. Now I was also experimenting. Well, now that I know this, I potentially don't need to use my if statement anymore. I can use this match. Okay, so match temperature symbol, but we know that this this format of the just like a string literal is going to come in as a found type static string, which also looking at documentation was the here I think it's reference str, but when creating it, you could like give it this right here, reference single quote static str. Like this is the prefix type. I think that's the right way to say it. And that's why this isn't working anymore, is because, okay, my character, well, not character, it's not worried about that. It's more of match. Temperature symbol is a full string in heap. This is a borrowed str, and so they're not the same type. I can't compare them. So what I need to do is convert these over to match what these are. So either convert this to a borrowed str, which that to me feels like the better way of doing this, as opposed to convert these over to strings. So that's sort of like the next thing for me to do here to make this work. And then I can say, well, if it's this F or F, then return the character F. And then the same thing with C. And then, hey, everything else, like just give me C or F. And that will, Felix, forget it. I forgot the panic. Where was the panic? Oh, this specific panic? I'm not sure exactly what you're trying to tell me there, but all right, continuing on. So that gives us the temperature symbol, which does need this conversion to work. That gives us the input symbol. And now we can do this match with the input symbol. Because input symbol is now a character, I can match across these characters. And also because I previously set what exactly it can be, I don't even think I need this here, but match needs it. Match yelled at me quite a bit. It's like, well, what if it's something else? And to me, I was panicking if it was something else, but Rust wants this just in case. So this message, like this should never happen. I'm not even sure how I would get it to happen, unless I guess it's because it's not completely confident, because it can only check types. It can't check logical stuff, which will happen at runtime. But basically, okay, well, if you're an F, we're going to now set the input temperature to, and then convert F to C, pass it the input temperature, And this is exactly the same as what we originally created. We pass in the 32-bit float. We were going to return a 32-bit float, and we just do some math. And that's what both these C to Fs and F to Cs are. So we do those, and then we have our final print line where we're just pass these in. Avarice, you could use unreachable there to indicate that the catch-all arm should never be reached. Unreachable, so unreachable looks like it has a bang on it, so that looks like it's a, what was the word for that? A macro? Is it macro? Try to enter an A instead of an F and see what happens. I first need to fix this, and then it will compile enough for me to do that. So let's go find, here's my browser. Let's go find the documentation for Rust, convert, what is it? String to the borrowed str. Because I haven't memorized these, and I probably never are going to memorize these. Is it? I doubt it's going to be on struct string itself, unless there's like a to. Into box string. That sounds interesting. As string. Brian Myers, welcome to the stream. As string. So, oh yeah, returns borrowed string. Extracts a string slice, contains the entire string. So as string, so one, let's see, what's the reference to self? So let s equals string from foo, assert foo, string s. Okay, so I don't need to pass anything in. So as str. Let's try this. If I do this as str like that, save it. Now it seems to work. All right, let's go run this. And first I'm going to do it correctly, and then I'm going to do Felix, your suggestion of passing in A, I think, right? But a better solution is just to do temperature symbol. Oh, wait, just to pass in. So reference to this, saving it. Code is still yelling at me. So expected, yeah, match temperature symbol. So that's what I have here. Expected type, reference to string, found type, reference static string. So it didn't like that. I mean, I suppose it's temperature symbol is a char now, not a string. Is that what happened when I reference it? It shouldn't be a char. Shouldn't be a char until after I do this. It would work if he returned user input as a string. Get user input as a string? Possibly. But I think what I like to do is this as string. Dot as str and do that, which converts this over into borrowed str, and do this. Try reference asterisk temperature symbol. All right, let's do that. All right, so not working state, reference asterisk. That does work. So I saw, Felix, in your article. I'm gonna call it a full article because that's what it feels like. It's a really good, awesome blog post. you used asterisk to destructure in the print line statement, as in first dereference the string and then take a reference again. What order is it running these in? Is it dereferencing first with this and then referencing it, or is it referencing then destructuring the reference? Unfortunately, I won't be able to like look at it anymore. So, to me, who doesn't yet know what's really going on with this, it feels wrong to do it because I don't understand it. First dereferences, then reference. That's the order. As in for, oh, okay. I misread a versus. I thought that said destructured there for a second. So first dereference the string, then take a reference again. Oh, that is super interesting. I think that once I understand this a lot more, I'm going to create maybe a wiki or something and start putting these things in here with descriptions, because memorizing this is probably not going to happen. You're implicitly calling the deref method. Ooh, let's go take a look at that. Deref. Is deref off of string? Why are these not in alphabetical order? Deref. Dereferences the value. So, okay. So dereferences the value for this. The documentation to read on this is the deref trait. Yes. Can I go? Oh, that just gives me implementations. And that's what we're, oh, okay. Traits, deref. Public trait deref, type target, function deref self target. Used for immutable dereferencing objects like *v. In addition to being used for explicit dereferencing operations with the unary asterisk operator in immutable context, deref is also used implicitly by the compiler in many circumstances. This mechanism is called deref coercion. In mutable contexts, deref mutable is used. Implementing deref for smart pointers makes accessing the data behind them convenient, which is why they implement deref. On the other hand, the rules for regarding deref and deref mutable were designed specifically to accommodate smart pointers. Because of this, deref should only be implemented for smart pointers to avoid confusion. That gives me another question. Also, you were looking at the docs for string, but temperature symbol is a character. Oh, I'm looking at the wrong area of the docs because it is a character. Yes, so if we look at it, well, so let's come back to here. So now we're trying to return a character, but temperature symbol itself right now is a string. And I'm trying to return a single character. So what I want to do right here is get the reference to the borrowed str to match here. I think that's where it gets a little bit confusing, and this is also like where and it's there's many ways to sort of like skin this cat here, where we can say like, okay, I can do as str, or can I also do Was it .deref? Can I also do a .deref here? Nope, deref doesn't exist specifically on that. Let me go find. We're on standard operation structs. I want to find string deref. Nope. Deref. Standard ops reference. Borrow cow. Cell collections. Wait, I thought I saw a string. No, allocate. I need to import deref. Is deref? Okay, so it's because deref is on. Wait, so here's the standard ops deref mute. Standard string deref mute. And I think there was a non deref mute, like standard string deref, right? Didn't I read that somewhere? Use standard ops deref. Okay, let's try that. Let's pull in standard use standard ops deref. Okay, so with that, no errors, that's fine. And then it just starts working. I thought I was going to use it as a function out here. That just makes it start working. I was not expecting it to just suddenly be accessible on all of the strings. I thought that this was going to do something slightly different. I thought I was going to use it over here, like deref. Okay. If I save it. Yeah, it's still not complaining. Input symbol. Get temperature symbol. Why are you claiming that you don't need to be mutable anymore? I'm assigning you right here. Get temperature symbol. Return to char. You're still returning this character, aren't you? Okay, let's try running it. I'm just going to ignore you for the second. What temperature you want to convert? Let's do 32 again. Is this C or F? We'll do F. Temperature is 0F. Okay, seems to be working. Because you initialize it, you don't assign it. It doesn't. Okay. This one needs to be immutable because it's set here and then it's set again here. Input symbol is set once. Okay, got it. That makes more sense. Thank you, Felix. All right, Felix, you suggested that I try A to make sure like that it handles that and doesn't like just poop all over my my application. So let's do cargo run. What temperature do I want to convert? I want to convert A. Okay, please give me a number next time. You can directly write let input symbol equals get temperature symbol. Let input symbol. Oh, yes. I could do that. And so that's something I want to know is what's the best practices for Rust? In other languages, best practices are to declare any variables you're going to use at the top of the scope. and then put them down here, because I want this print line to run first, I feel like I want to say explicitly, I'm going to be using these variables up here and then use them down here. But I could totally understand that like it doesn't need to happen that way. That's just sort of how I'm writing it. Okay, now that one works. Let's do like 45, and instead of A or C, we'll do C or F, we'll do A. Panicked, please enter C or F. Okay, so I got, you can do either, but most direct flows don't initialize variables without values if you don't need to. Okay, so the best, so taking Felix's advice is more common. Okay, so I can instead do let mutable input temperature and then just let at this point in time. Okay, I will. I'll start to do that in my code when I write it. I don't think I'm doing that anywhere else. Perfect. Okay, so what's, I got a panic. Not there. Where's my other panic? So I got panic here at please give me a number next time when I didn't give a number but A. And then also I got a panic here, please enter C or F. So I wasn't able to get this panic. And I think I can't get that because I'm matching specifically on these. So if I don't pass in F or C, it's just gonna hit that one. So I can't remember, was it looking way back in the chat now. Avarice, you mentioned you could use unreachable, the macro unreachable there to indicate that the catch-all arm should never be reached. So that would be here. Interested in how that works. Unreachable rest. Standard unreachable. Macro standard unreachable. A utility macro for indicating unreachable code. This is useful anytime that the compiler cannot determine that some code is unreachable. For example, match arms with guard conditions. That's exactly what I have. Loops that dynamically terminate, iterators that dynamically terminate. If the determination of the code is unreachable proves incorrect, the program immediately terminates with panic. The function unreachable, which belongs to standard intrinsics module, informs the compiler to optimize the code out of the release version entirely. There will always be a panic. Okay, so match arms. So here's where I can get, oh, I want to, when you run rust backtrace equals 1, you can see the line number where it panicked. So this is why I said panic is better than process exit. Only use it if it really can't be reached. Right, yeah. Unreachable basically does the same thing as panic, but to the coder, it lets you know that it's unreachable. Usable for readability. Yeah, that's sort of what I'm thinking here is that if it does hit this line, it's telling the compiler at runtime, or it's like setting this runtime code to like panic the heck out of this right now. So unreachable. Can unreachable take something in. Message. Yeah, I'm not. Ooh, so they don't have any, like there's this message here, and I don't know if that means that I can hand it a message, but it doesn't look like I can. So this would just be me, instead of saying like panic and then a message like, yes, you cannot. Yes, same as panic, a format string plus parameters. But I could see doing, okay, unreachable here. And just saying like, hey, this will never happen. Now, anybody else who reads this code knows that. Oh, wow. Felix, you're right. It is 8:03 for me. So, pretty much, yes. The cool thing is today I am working from home, so I don't have to like prepare and like actually commute into to work. So that's why the time is not quite as important today. But I think with this, I think we've got this temp convert over into a good place. So just I want to look through this really quickly. Push this code up, and then we'll be fully done. Thank you also, Felix, Brian, Avarice. Anybody else that I missed that's been chatting with me today? You guys rock. Thank you so much for putting messages into the issues on Learning Rust. Thank you also for stopping by and chatting today. This Learning Rust has been a lot of fun for me. It's also just something that I see is going to be extremely useful for me in the future working with it. But for now, just getting through it, learning this, it's super awesome, good time. So I don't need this anymore. We have our match symbol. I don't need this anymore. I do like the way these matches look. They're so much nicer than those giant ifs. And then save it. Let's run it one last time. Let's do like 250C. Ooh, that looks like a bug. If I do like 0C. Oh, look at that. It's giving me the correct thing, but it's not giving me the F of what's that switching over. So there is input symbol. If I have C, it does convert C to F. Oh, you know what I was supposed to do? And I think I completely forgot in my if statement is I was supposed to also, that's why this needs to be mutable. This changes. So input temperature, this is going to become a block. And then I'm also going to say input symbol is equal to the opposite, so C. I'm going to do the exact same thing here. And input symbol is equal to F. That'll do it. I want 99 degrees C. It is now 210.2F. Perfect. Exactly what we wanted. I am going to push these changes on up. Refactored to use match, not store everything in the heap, and clean up the methods. Ah. And more. And send it on up. If I found that if I don't do this like on stream right at the end, I will probably forget until the next day, which of course means that anybody that reached this video can actually see the latest code. So anyways, temp convert is for what I wanted to do and learn, it is essentially done. And tomorrow is Thursday morning. Tomorrow morning I'm going to be working on whatever the next one is. I can't remember off the top of my head. It's Fibonacci sequence. That's what we're gonna be working on. Anyways, thank you all for stopping by and watching this. It's been super awesome fun. For those of you who are watching the VOD, I try to do this every single morning. This upcoming weekend on Friday through Tuesday, I'm going to be out of town without quality internet, so I won't be able to stream in the morning, but we'll be starting back up again on Wednesday. But tomorrow morning, I will be here. Also, I am the co-organizer of the Node.js meetup group in Denver, and I generally stream these meetups. We're having a meetup tomorrow at around 6:30 is when we begin. So I'm not sure exactly when the stream will be. Watch my Twitter account. I have a link to Twitter in my description for the video. And I hope to see you guys there online if you want to take a look at that. Also, it's going to be someone's going to talk about setting up projects for quick iteration and getting your side projects going. All right, with that, it is 8:09, 8:10, 10 minutes after I normally leave. So again, thank you guys, and I'll see you next time. And click.